Let's go ahead and let's talk about the next question. This is actually one of the really tricky types of transformations. So our instructions tell us choose either b of x or c of x and determine their transformed equations based off of their parent function a. A, B, C is just how we organize them. We do have x values again, and again these just structure things to go across the table, so it provides a little bit of organizing, I suppose. If we look at the values for a of x, starts off with 1 when we're at -3. -2 still makes 1, and that can totally be allowed. You can make the same number again and again. It's just not very interesting. -1 makes 2, 0 makes 3, 1 makes 5, 2 makes 8, 3 makes 13, and 4 makes 21. So the tough part is to kind of see maybe the pattern through just the parent perspective. And this is something we'll come back to at the end of the year, but if you look at 1 and 1, what happens when you add those two numbers up is you get 2. If I take 1 and 2, what happens when I add those together? I would get 3. 2 and 3 would add to get 5. 3 and 5 add to get 8. And so this is kind of a strange type of pattern where you take some of the previous numbers and you sum them together. And so that's kind of a little bit more about Abraham, the father. In terms of getting b of x, the reason this is tough is because we don't start off exactly the same way. Bob here starts off with 2 and then goes 3 and then 5, 8, 13, 21. Then it goes 34 and 55. It's still kind of the same pattern. If you look, 2 and 3 is 5, 3 and 5 is 8. Even down here, 21 and 34 would still make 55. But what has happened is that things are not lined up the same way. You can kind of see that 2 and 2 happen in different rows. 3 and 3 happen in different rows. So it's a bit like this, okay? If I had copied Abraham's numbers, so straight over, this is just a plain old copy, Bob isn't a copy of Abraham's numbers. What has happened is that I have slid them one earlier in time, because think about the x-axis. This is a little bit over to the left of where -1 would have been. So normally 2 happens at -1, but now 2 happens all the way over here at -2. And then actually even more in terms of kind of a shift off placement is that 2 happens at -3, not normally where it would be occurring. And so every single row, every single shift, we're moving Bob to give us the pattern earlier and earlier. That would be on the left side of the graph. So if you think about what that would be as a transformation, that's actually a transformation inside because you're offsetting its x orientation, how things are lined up in its x values. So sometimes you will see me put my fingers together, and so when I'm doing that and I shift my fingers off by one row or off by another row or off by that final row, we are dealing with x horizontal transformation. So Bob here, b of x, is equal to the parent. The parent's name here is a of x. And notice how I left some space in here because it's not the normal parent, it's the parent shifted 2 rows off. And so how do we do that? Well, if you think -2, that's pretty close, except that as a direction, -2 is to the right. So this needs to be a +2 because we're shifting it to the left. We're shifting it 2 earlier in its progression. That actually kind of helps us with C because it's the same type of transformation. But you'll notice having 1, 1, 2, and 3 doesn't happen until way down here in the table. So it's not the normal connection of values. These connect way down. And so apparently the numbers that would have maybe been preceding our parent, and like if you think even earlier in time, these would have been 0, 0, 0, 0, I guess, because that's what we're starting to see with this kid, so Carl. So Carl's numbers do not normally happen at -3 and -2 and -1. They happen at 1 and 2 and 3, which is an offset of 1, 2, 3, 4 rows. So Carl of x is equal to Abraham. but I would need to shift it 4 rows away because it doesn't happen here or here or here or here, but it starts to happen later, 4 units later. I would not combine this type of a transformation with a doubling usually, or even an offset of like adding to the end or subtracting to the end, because that really starts to make it less apparent that that has happened. So typically with a horizontal transformation, that's the only thing I will try to give you, because otherwise it's super tricky. So again, you only had to choose one of those, but just in case you wanted to see the pattern with both, I gave you the answers for B of x and for C of x. Hopefully that helped and makes a little bit of sense. Take care, guys.